This is Learning Assessment Problem E228. In this problem, we are to determine a voltage VO appearing across a 2K resistor. The problem has a dependent current source in it, so the problem-solving strategy here is that of circuits with dependent sources. We'll consider labeling nodes A at the top, the circuit B at the bottom, and we have this node C at the junction between the two resistors. We should recognize that there is no current flowing out of this wire. This is just indicated as a measurement point for the voltage VO. We'll label currents in the other branches of the circuit I1, I2, I3, I4, and we should recognize that the same current I3 also flows through this 2K resistor. So we'll do a KCL expression . We have this dependent source, and the voltage dependence is that the current is the voltage VO divided by 2000. Since that's a current, the units of the 2000 will be ohms, and in order to be consistent throughout the circuit, it would probably be wise to make this a 2K in that denominator rather than 2000, so that we have the same units of kiloohms around the circuit. Now we need a relationship between the V0. We have a voltage V sub S labeled between the nodes A and B, and that will be our working voltage to determine the various branch currents in the resistors. We need a relationship between the V0. We need a relationship between the VO controlling voltage and the V sub S. We see in the VO circuit that VO by a voltage divider relationship will be 2K times V sub S, the total voltage between nodes A and B, divided by 1K plus 2K, the series combination of resistors, or VO is equal to 2/3 Vs. Now we can proceed with a Kirchhoff's current law summation of currents at node A. Now we can begin with a Kirchhoff's current law summation of currents at node A. We'll have I1 plus I2 plus I3 plus I4 equals 0. Now we'll substitute in expressions for those various currents. The I1 is the strength of that dependent source, which is a minus VO divided by 2K. The I2 will be defined by the voltage Vs divided by the resistance in that path, 6K, plus I3 plus I3 will be the voltage V sub S divided by the sum of the resistors in that series path. And then the I4, and then the I4 is minus 2 milliamps, since it is flowing into the node A. Now we can substitute that VO is 2/3 Vs and write minus 2/3 Vs divided by 2K plus Vs over 6K plus Vs over 3K is equal to 2 milliamps. We can cancel some terms here. The Vs's over 3Ks are opposite sign. They will cancel. And we obtain that Vs over 6K is equal to 2 milliamps, or V sub S is equal to 2 milliamps times 6K is equal to 12 volts. And finally, we can use our expression that we determined for the VO in relation to Vs and find that VO is equal to 2/3 times 12 volts, and that is equal to 8 volts. Now let's look at how these currents sum up. We have that I1 is minus VO divided by 2K, so that will be minus 8 volts divided by 2K, which is equal to minus 4 milliamps. I2 is Vs divided by 6K. Vs is 12 volts divided by 6K is equal to 2 milliamps. I3 is Vs divided by 3K, or 12 volts divided by 3K is equal to 4 milliamps. And then the I4 is equal to the minus 2 milliamps. And we see that the sum here is just 0, as we would expect.